Here is a brief introduction on PowertrainLive. PowertrainLive is a vehicle performance simulation tool that allows you to quantify the fuel economy impact of various technologies you're developing. PowertrainLive allows you to build models from scratch or start from one of the pre-built vehicle models. PowertrainLive provides standard vehicle models pre-populated with vehicle data. Engineers at CSEG spend significant amount of time analyzing the transient dyno data collected on these vehicles and have extracted the performance data of key subsystems such as engine, transmission, battery, and power electronics. These vehicle model predictions correlate well with transient dyno data under various drive cycles. Populated vehicle models that have been validated with test measurement means that you have reliable vehicle models in which you can have good confidence. It's like having a virtual mule vehicle readily available. Your team doesn't have to be experts at vehicle level modeling or internal simulation codes. PowertrainLive standard models will have saved you months of modeling and correlation work. You can just focus on changing parameters related to your subsystem and study its vehicle level impact. You can take any of these standard models and make a copy of it as a user model. Of many of our populated models, we have shown two models here, the Ford F-150 and the Suzuki Swift with a 1.2-liter engine. Let's look at the Ford F-150 vehicle model shown here. The icons on the left show the major subsystem in this vehicle model: the chassis subsystem, the engine subsystem, the transmission subsystem, wheel, driver, environment, brake, and miscellaneous such as waste heat recovery. The section in the left is used for input parameters that are numbers such as vehicle weight and engine idle speed. The section on the right is used for input parameters that are maps such as engine torque curve, fuel consumption map, throttle map, etc. Each of these maps can be investigated right there as they are dynamic maps. You can zoom in into the map and look at the different data points. In addition, the data for these maps is immediately available by clicking the Data button right next to the map. Here, the data can be viewed, changed, and pasted from Excel if you want. You can also upload the data from an external CSV file. Here are some of the maps that are input for the engine subsystem, such as the brake torque curve, fuel consumption map, engine heat rejection map, exhaust mass flow, etc. There are many input variables, and perhaps of particular interest to the thermal management teams would be the warm-up profile and the mechanical and electrical accessory loads. These parameters can be changed from the surfaces below here, but we'll cover these in much more detail in a later video focusing on thermal management. Let's look at the transmission subsystem. Similar to the engine subsystem, the parameters that are numbers such as shift time are shown on the left. The parameters that are maps such as upshift and downshift are shown on the right. The drive cycle for the analysis can be changed in the driver subsystem. You can change the drive cycle by changing the data. If you are running a performance analysis and not a fixed drive cycle, you can impose the accelerator and brake pedal position. Let's run an analysis. To run an analysis, we will first create a scenario. Let's call our first scenario a baseline scenario. Once the scenario is created, you will go to the Run Simulation button and run the simulation. This will save all the data from the graphical user interface and run the simulation. Once the simulation is performed, we can go into our scenarios and look at the results. First, let's look at the summary results. We can see in the summary that 4 key parameters have been reported. The cycle average fuel economy, which is shown as 18.59 mpg, the total distance traveled, 11.04 miles, total fuel consumed in the drive cycle, 0.59 gallons, and the total CO2 emitted in the drive cycle by the vehicle, 3.51 pounds. In addition to the summary results, one can go into each of the subsystems and look at the individual parameters calculated for the subsystem. So let's look at the engine subsystem's parameters. In the engine subsystem, different parameters that are reported are cumulative fuel consumption. So for the given drive cycle, you can see how the fuel is being consumed. Instantaneous fuel consumption, what the engine speed is, the engine torque, what the cold engine friction torque is. This is the additional friction in the engine due to a cold engine. What the estimated engine heat rejection is. This is very valuable if you are running a co-simulation with other programs that might need boundary conditions of heat rejection from the vehicle model. In addition to that, it also has estimated exhaust mass flow and estimated exhaust temperatures from the model. Now let's run a what-if scenario. For this what-if scenario, I will change the vehicle weight. I have increased the vehicle weight by 300 kilograms. And so let's create our new scenario called higher vehicle weight. And go and rerun the simulation. Once the simulation is complete, we can go in, look at the higher vehicle weight result, and look at the fuel economy. You can see that the cycle average fuel economy has dropped to 17.78 mpg, and the total fuel consumed and CO2 emitted have gone up. You can also look at the individual parameters, but since we've already looked at them, I want to show you how you can compare the individual parameters by selecting both results at the same time. So I have selected our previous analysis baseline and the new run that we did. Let's look at the different parameters in the engine subsystem. As you can see, now the results are plotted for both the scenarios that we ran, one with the baseline and one for a higher vehicle weight. And we are able to zoom in these graphs trying to see what the individual values are at different times. That brings us to the end of the introductory video on PowertrainLive, a powerful cloud-enabled vehicle performance simulation tool. Look for our other videos on specific applications in the near future.